we might get a question like this asking us about collinear points. Here's the deal. Collinear points are in the same line. Of course, any 2 points are collinear. 3 points is a little bit of a different story. Coplanar means in the same plane. So any 3 points will be in the same plane. They're not necessarily in the same line. We're concerned with collinear points. So collinear points are in the same line, not vectors. Collinear points are in the same line. And here's our statement. If the vectors are parallel, then the points are collinear. I'm asking, are these 3 points collinear? Well, as long as I choose any 2 vectors that encompass the 3 points. In other words, I can't pick vector PQ and vector QP. I have to somehow include point R in this. So it doesn't matter which points you choose as long as you incorporate all 3. So we could say, well, what about PR? Vector PR is final minus initial, -6. Final minus initial, -1 minus, -11 minus -1 is -10. Final minus initial, 0 minus 4 is -4. There is my vector from P to R. Now I can pick another one. How about QR? It doesn't matter which ones you choose. QR would be final minus initial, -9. Final minus initial, -11 minus 4 is -15. And final minus initial, 0 minus 6 is -6. And if these 2 are parallel, then the points are collinear. Let's see. -6 over -9 simplifies to 2/3. -10 divided by -15 simplifies to 2/3. And -4 over -6 simplifies to 2/3. So I can't say that vector PR is equal to vector QR. What a ridiculous statement. They're not equal. Which one is bigger? Well, clearly QR is bigger. So I'd say 2/3 of the big one is equal to the small one. Or you could say 3 over 2 PR is equal to QR. They are parallel in the same direction because I can write one vector is equal to a scalar multiplier of another. Because the scalar multiplier is positive, they're in the same direction. I chose 2 vectors that happen to be in the same direction. They encompass the 3 points. I can say because the vectors are parallel, then yes, these points, the answer here is yes, these points are collinear.